So, welcome. So, here let's begin the topic by talking about baking soda. Our baking soda here, the formula will be NaHCO3. I hope you remember this compound. What was it? Sodium hydrogen carbonate, or it was metal hydrogen carbonate. Okay, that metal hydrogen carbonate, if the metal given is sodium, we call it, or we give it a common name. What is the common name here? Baking soda. So first of all, let us learn how to make baking soda. So I told you NaCl was very much important. Why? Because it was a very important raw material. From this we could get NaOH, chlorine and hydrogen from chloralkali process. Here again from NaCl we're getting baking soda also. So what do? You take NaCl plus H2O plus carbon dioxide and NH3. NH3 is ammonia. Okay, then what will you get? You will get ammonium chloride, NH4Cl plus our baking soda, NaHCO3. So this is the only reaction which you have to remember again. Okay, it's a complete new reaction to try to remember it. Here this is ammonia, NiA. This is NH4 is ammonium. Okay, ammonium chloride. So here this reaction is necessary, very important. So you will get a question. uh, Write the formula for baking soda. This is the formula NaHCO3, and this is not a big thing to remember. Why? Because we already know metal carbonates or metal hydrogen carbonate. It's metal hydrogen carbonate, but in this case the metal is sodium for baking soda. Next you'll get, write the reaction to soda, or the reaction by which we produce baking soda. So this will be the reaction. NaCl plus H2O plus CO2 plus NH3 will giving us NH4Cl plus baking soda. So here the important thing is what happens when we use baking soda. Okay, here why is baking soda needed? First of all, let us see the reactions. So if you take baking soda, why will you use it? Obviously we'll use it in baking cakes and all. So let me talk baking soda only. Baking soda, suppose when making cake, what do? You will take your atta. Okay, this your atta or maida, whichever you do, I'm not so sure. So you take it, you put water along with it, and you put some amount of baking soda with it. So suppose two people are there. This is suppose person A and this is person B. Both of them did the same process, but person B did not put the baking soda. What difference will be there? The difference will be the person A's cake will be very fluffy or spongy. Person B will be very tight or not at all spongy. Why? Reason is baking soda releases carbon dioxide when heated, CO2. And when you cook the cake, when you heat it, then lots of CO2 will come in bubbles form. Bubble will be there. Okay, the bubbles will come up, and afterwards this gas will escape, no problem, but the bubbles will remain inside. So when you eat the cake, you know it already, there are lots of holes inside, small holes, or like this small chambers are there. The more the space is inside the cake, the more spongy it becomes. The less or the little space it has, the more less spongy it becomes. So this is the reason why we need carbon dioxide to be formed when in baking cakes or in making certain, like for example, what was it, in making bread also we already learned, we use algae. Yes, not algae, what was it? Fungus, a fungus. Yes, we use a fungus in making our bread. And what was it? Because the fungus undergo abiotic, what was it? Not abiotic, sorry, a reaction, chemical reaction without oxygen. What was the name? It just skipped my mind. Wait a second. Anaerobic. Okay, our yeast, okay, fungus yeast, it will undergo an anaerobic reaction to produce ethanol plus carbon dioxide. That CO2 is the one which is making the things fluffy, okay, spongy. So here, when we're talking about baking soda, let's see how it happens or how does it help the cake to become spongy. So if you take baking soda, NaHCO3, and you heat it, okay, it forms something called as Na2CO3, plus some water will be released, plus some carbon dioxide will be released. Okay, this is a new reaction. I'll compare it with one more reaction which we know, so don't worry, we'll do it. Okay, so here, so this carbon dioxide will be the one which will make the, what is it, bread or our cakes fluffy. So here we're talking about what, baking soda. Now instead of baking soda, you can use baking powder also. Baking powder. What is baking powder? Baking powder is nothing but dry baking soda in powder form. That means powder form plus some acid, some edible acid. Edible means some acid which we can eat, which will not harm us. So here we're talking about baking powder is what, baking soda in powder state and with acid in complete dry state. Okay, powder means what, it is dry. So let me take NaHCO3. Okay, just to make it simple, let me put HCl. We will not put HCl generally, we'll put some other acid which we can eat, but just to understand, let us say we're talking HCl. We already know acid plus metal carbonate, metal hydrogen carbonate. What do you get? Salt plus water plus carbon dioxide. That means this reaction will take place. Yes or no? No. Reason is I'm talking this whole setup is dry. Dry meaning what? Acid is not behaving like an acid. As a result, is the reaction taking place in a bottle of baking powder? No. The bottle containing baking powder will not undergo any kind of reaction because the whole setup is dry. Now, when you want to make cake out of it, do you put water along with it? Yes. Now, will the acid behave as acid now? Yes. Now, the reaction take place to become salt. How to write salt? Remove the H, put the available metal, cross the valency, 1 1, no problem. Plus, what do you get? Because H got kicked out, H got kicked out, C got kicked out, O got kicked out, HNO, H2O, CNO, CO2. So we're getting carbon dioxide gas here also, and this will be the one which will make our cakes fluffy. So I hope you got this point. So what is baking soda? NaHCO3. What is baking powder? It's dry baking soda with already pre-mixed with some kind of dry acid. And because it is dry, the reaction is not taking place. But as soon as we use it to cook, we will mix water along with it. When we mix water with it, the acid will now start behaving as acid. The reaction will start to take place. So what will we produce? CO2 will be produced, and when CO2 produce, whatever thing we're cooking will become fluffy or spongy. So got it? Now to compare these two reactions, here we're taking baking soda. Instead of HCl, we're heating it. Okay, we're getting water, CO2. But here we're getting something called as Na2CO3. What is this? Sodium carbonate, or this is metal carbonate. This was metal hydrogen carbonate. It changed into metal carbonate. The H got kicked out. Okay, so here we can see in page number 31, the first use of hydrogen carbonate or baking soda is given here in making a baking powder. Okay, and we already learned the baking powder here. In the reaction, you can see it's given NaHCO3 plus H plus. Why H plus? It's not given HCl because here H plus means some acid, okay, which we can eat maybe. So here it's given, instead of NaCl, it's given sodium salt of some acid. Cl is not present because in the book Cl, we're not using Cl. so we'll not get Cl here, we'll get Na something else. That something else is given here, sodium salt of that acid. Okay, second part is given, sodium hydrogen carbonate is also used as ingredient antacids. Antacid means what? Our, when we suffer from gastric problems, like our stomach burns, then that medicine which we take is called antacid. Why? Because NaHCO3 is basic in nature. Okay, so our sodium, what is it? Sodium hydrogen carbonate or baking soda is basic in nature. NaHCO3 is basic. As a result, it will react with the acid in our stomach. The acid in our stomach present is HCl, and when we are suffering from gastric problem or when our stomach burns, it's because too much acid is released in your stomach because of some problems. These problems we can discuss when the school reopens. Okay, or I think we discussed already in chapter 5, that because when too much acid is produced, that time what happens, our stomach will burn. So to cancel that acid we need some base, so we are taking NaHCO3 because it is not a base but basic in nature, so it can cancel or it can behave like a base and cancel the acid, and ours it will neutralize it. Okay, and it's given, it is also used in soda acid fire extinguishers, or what they do is they take acid, they take soda, and when acid and base react, here the reaction form will be, we'll get some carbon dioxide produced, and that thing is used in fire extinguishers. Okay, so that was all about our baking soda. So our next topic is washing soda. Compound is Na2CO3. Just earlier part we got this compound. Let's cross the valency, sodium and carbonate, valency 1, valency 2, so cross Na2CO3. Okay, where did we get it? We got it when we took our baking soda, NaHCO3. Instead of putting in acid, when we heated it, we got something. That something was Na2CO3, plus we got our normal general, what we get, water and carbon dioxide. Okay, so this is what we call as the washing soda. Now when writing washing soda formula, always remember to put dot 10H2O. Let's try to understand this meaning. Okay, so here we have got one more compound. Let us say CuSO4 dot 5H2O. I hope you remember CuSO4, or you can say the name also. What is the name of CuSO4? This is copper sulfate. Okay, so copper sulfate is also a kind of salt. Na2CO3 is also a kind of salt, because generally we get it by reacting acid, base and also. Okay, so before going into that, I want you to go to page number 32 and check for the uses of washing soda. It's given it's used in washing glass, it's used to make soap and to wash papers and all. It is used to make sodium compounds and borax. Borax is what we use to generally kill the ants and all. Okay, sodium can also be used as cleaning agent. It can also be used for removing permanent hardness of water, which we'll see later on, hardness. Okay, when we get chapter 4, our carbons. So here what I want to focus is about that 5H2O or that 10H2O. So for CuSO4 I wrote dot 5H2O. What is the meaning? Let me assume this is a CuSO4 molecule. I have got 2, 3 and 4 CuSO4 molecule. Okay, then what we will find is, for every CuSO4 molecule, it will have 5 water molecules with it. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5 water molecules. Okay, one CuSO4 will have 5 water molecules. And copper sulfate, what was the color? It was blue. Yes, so here this whole thing will look as blue. Okay, now when you check it, is water present there? Yes. Will it feel wet? No, because Why no? Because this 5 water molecule is not moving around here and there. These 5 water molecules are stuck with the copper sulfate. It is stuck with it. As a result, the whole setup is not wet, it is dry. But let us say you mix some more water, then those water will remain here and there. And those water is the one which will make it wet. Okay? And what do? Slowly you heat the water, then the water will dry up, and when the water dries up, what happens? Those 5 water molecules remain inside and it will become dry again. So these 5 water molecules is part of the compound itself. Okay, without these 5 water molecules, the compound will not behave like CuSO4. For example, if I heat this directly, because when I heat it, what happened? This water will be removed. As a result, the copper sulfate will become white in color, and it will not react as it should react because it lose the water now. I hope you got it. So this is the reason why in purification of salts in class 9 we learned, we used a process called as crystallization. I already told you. We never took the salt. Suppose we had a salt, okay, we mix with the water. So I have got some amount of salt here, water is there, and what I did was I allowed this water to slowly evaporate. I did not heat it directly. If I heat it directly, the water will evaporate very fast. So I'll get the salt very fast. But problem was, if I heat it directly, or if I use evaporation, what was it? Heating technique or boiling it, then what will happen? The water will go, and whatever water the salt actually needed, this 5 water also will go along with it. As a result, the dry salt will remain, and the dry is what a chart, it's not used or not of any use to us. But when we allow it to evaporate slowly, the excess water will evaporate, but for CuSO4, those 5 water molecule will remain with it. As a result, this is what we call crystallization. In crystallization technique, we do not heat directly, we allow it to evaporate slowly. When it evaporates slowly, only the excess water evaporates, and whatever is needed for the salt to behave normally will remain with the salt. It will not evaporate anymore. But if you heat directly, all the water will go away. As a result, the salt will not behave like a normal salt. Same goes for our washing soda. Our washing soda, it was Na2CO3 dot 10H2O. That means our 1 Na2CO3 contains how many water molecules? 10. If it gets 10, then it is normal Na2CO3. If it becomes more than 10, it will become complete weight. If it becomes less than 10, it will get damaged. So I hope this part is clear. So here, the last and final topic here is our plaster of Paris. So the formula will be CaSO4 dot half H2O. Okay, that means for every CaSO4 there is half water molecule. But how can you break the water molecule into half? You cannot break it. So the actual meaning of this is, for every 2 CaSO4 there is 1 water molecule in between them. Got it? So in this case, this actually should have been 2 CaSO4 dot 1 H2O, but we divided by 2 to make it one single SO4, so it becomes half H2O. So I hope this is clear. Meaning of this statement is, for 2 CaSO4, 1 water you will find it. Okay, and this is in the form of a powder. Got it? Now what happens is, if I add water to it plus H2O, let me write 1 half H2O because that's what needed, then it changes into CaSO4 dot 2 H2O. That means now what happens, if I take CaSO4 and every single SO4 I give 2 water molecules, it becomes some other substance. See, this is the meaning. In our CuSO4, it had 5 H2O. It was normal. You remove the 5 H2O, it was something else completely. It was no use for us. Same in CaSO4, half water is present. It's something. It's powder. Okay, that thing is what we call as plaster of Paris. I gave little water, it became 2 H2O. Now every CaSO4 got how many? 2 water. it becomes something completely else called as gypsum. And gypsum is very hard, and this is the one which we use in your fractured arm, the plastered or white color powder, that is plaster of Paris, and the hard substance is gypsum. Thing is, what happens when your hand or leg breaks, the doctor will put bandage around it and put a white color powder, mix it in water and put it around your hand, and that white color powder is CaSO4. Now in that CaSO4, every CaSO4 had half H2O. So what happened here is he put lots of water, maybe 10 water, 20 waters more than necessary. Now what happens? The water will slowly evaporate and will dry up. When it dries, that CaSO4 will now capture two water with it, okay, and convert into something called as gypsum. And gypsum is very hard. The X, suppose he was putting 10 waters, the CaSO4 actually had half water. Now he put 10 extra water. Out of the 10, one half it will capture, CaSO4 will capture the one half to become Ca2SO4. The remaining, suppose our 8 half, will evaporate and go away. And when it becomes dry, it becomes very hard, and that is how our plaster works. Okay, so this gypsum can, or plaster of Paris, can be used to make soft our toys also, some decorative toys and all. So this is what about our plaster of Paris. Now the only important thing I'm going to say from here is, most of you are going to make mistake here. The most common mistake, CaSO4 dot half H2O. What is this? This is the formula for plaster of Paris. You are going to write CuSO4 dot half H2O. What is the difference here? There's a single letter. A, by mistake you wrote U. Is it a very big issue? Normally, if writing sentence, not a big issue, but here it's very big problem. You are going to get 0 mark for CuSO4 dot half H2O. CuSO4 is copper sulfate. This is calcium sulfate, and calcium sulfate is the one which we call plaster of Paris, and its reaction with water, 1,1/2 H2O, giving us CaSO4 dot 2H2O. 2 marks. They'll give you a question, write the formula for plaster of Paris. This is the formula, and for 1 mark they will ask you write its reaction with water. CaSO4, you will write the formula plaster of Paris is CaSO4 dot half H2O, and you will write the next statement, that reaction is CaSO4 dot half H2O plus 1 half H2O, giving us CaSO4 dot 2H2O. 2 marks. Got it? So very easy. Most common question in almost every metric exam, most common question from chapter 2 is this: write the formula for plaster of Paris. Or you can see your question number, page 33, your question number 5. Very important. They will come for 1 or 2 marks. If you're lucky, the same question comes for 2 marks, or sometimes they add extra part, write the formula of plaster of Paris. Okay, CaSO4 dot half H2O. So be careful not to make mistake between Ca and Cu. CuSO4 is copper sulfate, and it will always take 5 water. Okay, so I hope you understood this part. I hope you remember this part. So this was your chapter 2. So if you have any kind of doubts, you can personally message me and you can ask me, no problem, or you can wait for the school to reopen. Okay, so thank you.